So the unfortunate events that were just pointed out on stage, it's actually a perfect segue because after spending 2 years at Blockstream and having to deal with the brunt of the vitriol launched towards somewhat justifiably, somewhat unjustifiably, towards a group of people who have committed a lot of time and energy towards something. And it really serves as a reminder of the human aspects that I think are often forgotten, as many of us are technologists. And I hope in this presentation that I can outline exactly why that's an important thing to consider and what we can do about it. And in fact, it might actually be something that we can turn into a positive. We can leverage it. So this obviously is Timothy Berners-Lee. He was considered the father of the World Wide Web, not necessarily the internet itself, but the World Wide Web, which is you can think about it like an application that sits on top of the network. The network is the internet, and it attempts to be as decentralized as it could at the time. But this is what he said when he really wanted to, he was frustrated with the state of how things unfolded. So he said, you know, he wants something that's open. He wants something that's accessible to everyone, something that people can have easy access to. And it works as well as possible. We all know that technology never quite deploys exactly as you want it to, and we'll get to that in a minute. But it's not nation-based, right? So right now we're sort of living in this world where, depending on where you live, depending on which geographical border you happen to reside in, or just simply be present in for whatever reason, your internet is controlled and governed. It's different based on where you are. Content is restricted. It is not accessible from one location, but with a quick VPN hop away, it is accessible. So it's not quite what was imagined when Timothy Berners-Lee started the project. But what did make the web great? Like, what was it that actually gave us value and the things that brought us this robust economy that we see today? Well, number one, it gave us freedom. It was actually really easy for anyone to get access to the internet once you had an ISP or you go down to your local library, and once things kind of came online, you had the ability to publish. So you could share your thoughts with the whole world without having to go through a publishing house. You didn't have to compile a large book and go through editorial review. You could literally just put a document on the web. This was an incredibly, incredibly powerful thing for a lot of people. It really brought about an entirely new community of people that weren't previously able to connect or talk to others about whatever it is that their interests were. Because, you know, local geographical regions, they're smaller. The diversity may not be as high, and you can't necessarily find someone locally and physically to discuss these ideas with. But when the World Wide Web kind of came online, it suddenly became accessible to anyone with internet access. Anyone who had access to this network was going to be able to share their thoughts and ideas and even discuss them with one another. In fact, it's pretty incredible to kind of watch the growth. This is actually, you'll see most of the growth happens after the 2000s and the dot-com bubble. But in the early web, people were putting content online and directly communicating with one another. This is the total number of sites that were actually online over the past 15, 20 years. And it's really incredible to see this huge explosion at the end as, you know, the world economy starts to migrate to properly digital services. So this is the world we're living in here on the far right. I'll go back there for just a second. Number two, it gave us context. One of the most powerful things about the World Wide Web was the fact that not only were we getting documents and information that were thoughts that maybe we hadn't been able to encounter before, but HTML itself, a content markup language, allowed us to add metadata and extra information, context clues about what it was that we were viewing. And this is actually exactly why so many of these large institutions, Google in particular, were able to make so much money, is because they were able to crawl and understand the structured data that was actually already a part of all of these documents. So when you add an anchor tag in HTML and you give it some text, I mean, back in the day, of course, it was SEO and how to optimize for search, But there are properties that you can also assign in the A tag that allow you to indicate what kind of information this is. This is an example from actually 2012, the metadata in use in the search results. You can see actually here's one of my favorite things is the listings of song tracks and how long they are, what album they come from. I mean, you can imagine just simply pulling this from an HTML table. But there's something called microdata and microformats that allow you to mark up content and be very specific about saying that, hey, this is a list. It's a list of songs that belong to this collection. And what that allows you to build is a connected network of ideas and thoughts. So rather than just simple blocks of content, now we can link ideas inside of that content to other larger documents. And this becomes very attractive to the machine learning folks in the room. Number 3, discoverability. So in addition to, just like I said, Google, these guys having the ability to crawl through and find content. All of these people are publishing all of this information out there. So how do I sort through it all? And this is where the role of the great search engines kind of cropped up. But it was possible because this information was open. It was public. When you published an HTTP server, a document on an HTTP server, it was known that you could, at this URI or URL, you can directly access this document and that server. It's actually in the URI specification. It's called the authority. You will be able to retrieve that document from that server. Now, sometimes those servers were down, but we'll have some answers for that here in a bit. And they can also refuse service, right? So this is a challenge. But what was really exciting was that good ideas became very easy to find. And this was true for a period of time. For the past 4 or 5 years, as the volume of information, as the rest of the world has come online, we're suffering from a signal-to-noise ratio problem, where there's just so much information out there, you have no way of discerning what's accurate versus what isn't. It seems like that this is a very difficult problem, because now we've got this lovely network, but it's full of just, oh man, I don't know if you guys have been on Twitter lately, but it's a mess. But it turns out, though, that people are curious creatures. Who had any idea that search would become such a powerful vehicle for revenue opportunities and for information discovery? Again, this is really starting in at the end of the dot-com bubble and the expansion of search. But this is, I think that's actually, yeah, what is it, 1.2 trillion searches, right? And that's in 2012. Right? And things have continued to grow exponentially since then. And since we don't really, we really prefer our privacy, here's the DuckDuckGo results. You can see, actually, there's like a little taper. It starts to tape, the growth starts to taper off. And then here you can see exactly the dates at which DuckDuckGo sort of starts picking up, which is fantastic. Good to see people actually protecting their own privacy. But what didn't it give us? What didn't the web give us? Why are we stuck in this position that we are? And really, it didn't give us privacy, didn't give us security, and it certainly did not give us that crypto utopia that we were all hoping for when the world came online and had access to information. That's definitely not where we are. Might be where we're heading, though. So what happened? Why? Why did that happen? The very first flaw in the design of the World Wide Web was it's explicitly centralized. The idea of downloading a document from a server somewhere explicitly grants that server the ability to censor you, right? If you're requesting a document, it can, for whatever reason, just simply refuse to serve that document. In fact, that document could actually just be deleted. Someone could delete that document. Even if you chose to publish it to that server, it can be deleted by whoever operates it. And that's a very serious challenge because, you know, sometimes not only do those servers decide to delete data or maybe even just are overloaded because they can't service your requests, so they break, but a lot of the time, you know, people break into them because after all, if there's all this information sitting there on a server, why would I go steal it from every individual when I could just go to the server and just grab it all? So we see that. The internet and the World Wide Web both came early. In fact, if you recall, it wasn't until the mid-90s that actual citizens, as opposed to the military, had access to strong encryption. There was a huge legal battle in the early 90s to claim the right for us to encrypt information. If you recall about PGP, as I hope all of you do, it had to be printed in a book to bypass the laws. And even then, it was a huge question of whether or not it was arms trafficking. To tell people, to teach people how to encrypt and keep their own privacy was considered arms trafficking. Come on. So encryption was added later. And at the end of the day, when the default is unencrypted and everything is sort of open and public, it's, as many of you know, it's really difficult to kind of convince people of the importance of their privacy. It's taking massive upheaval in the world and incredible revelations by the likes of Snowden and the Panama Papers and so on to understand why this is so important. And people still are just not energized about protecting their own privacy. Users can't seem to be trusted to care. And last but not least is the theft of value. And I think there's actually one more point. But when you perform activity, and I think we're fairly familiar with this, most of the big companies on the internet operate this way these days, where in exchange for your attention and the information that you're producing, for example, not just when you write a Facebook post or you write a Medium post, and that's your content that you're choosing to publish on their server, but the additional activity that you perform, your simple browsing activity, is a piece of information that you are generating. That is your information. The fact that you accessed a website, that you own that. You own that fact, right? So, but there's big companies out there that are reselling that fact to their advertisers, for example, and that is where they make their money. If you don't pay for the product, you are the product. And so all of these digital services that we're using that are free, and it's not actually free, they're just concealing what you're paying them with. You're paying them with your information. You're paying them with your data. And in return, you get this service, but they get to control it. So there's a bit of an imbalance in the social dynamics. The control of information, the knowledge about how these systems actually work, what's actually going on there, is kept in the hands of the big companies, and the population is not informed as to what's going on. That can be a challenge because the business end of these companies, it doesn't always align with the real world outcome. One of the cases that I really like to point to is how Facebook kind of jokingly said, we have so much influence and power over people, and this was during the election cycle in the United States, we could totally change the election if we wanted to. And then it comes out later, of course, that they permitted, Russian agencies to purchase ads on their platform, which very directly appear in the stream. And a lot of people scroll past them, but a lot of people click them too. That's where Facebook makes almost all of their money. We have to consider the fact that at the end of the day, user is such an unfortunate term, because it implies that there's some sort of, to me it implies that you're sort of a second-class citizen. Users are people too, right? It's a two, when you produce code and you distribute a binary, for example, I hope you're distributing source code, but when you distribute a binary, your user is providing some sort of energetic input, right? They're putting their thought process into it, they're using it for their work, they're producing something of value. So we have to consider not only the fact that the technology might work great, the ideas might be seamless and it seems to work on paper, but at the end of the day, users are people too. They have emotions, they have passions, they have differing opinions, and ultimately they're putting their life and energy into the system. So we have a responsibility as software engineers and as developers and artists and people who help produce high-quality software to really consider what are the real-world implications of the people who will be using our software. So where did this leave us? I'm sure you've heard about some of the high-profile hacks at this time. In particular, most recently, the Equifax hack, I think it was just about every adult citizen in the United States. Anyone with a credit card account or loan account or even a bank account was practically included on this. And it was directly a result of the centralized data storage. I mean, when you have this ability to aggregate such a massive amount of information into one place, it immediately becomes a target for what happened to Equifax. This is some research that I did while at BitPay, and I haven't even bothered to update it because it just gets worse and worse every time I look. This is 64 million that I was able to track in the US alone. It's 20% of the US population in 1 year. Imagine what that does over time. And here are the major ones that I counted and the announcements. Some of them with the plus signs didn't even know how many records were actually stolen. They had no way of knowing. They didn't even really have a good sense of how poorly their network was or how badly their network was compromised. This is the chart. It roughly looks exponential to me. This is an incredible amount. Credit cards are being attempted to be fixed with chip and pin and all of this so on, but it really just doesn't work. So this is just a prime example of how money can be stolen when you have these centralized honeypots that are easy targets. And of course, people generally, if the system's working fine, it's very difficult to convince people to do an additional security audit or a quarterly security audit, heaven forbid, let alone when you're a large company making tons and tons of money just holding information. This is really my only response. I almost put the WAT statement, but fortunately, I really think this is worth a total WTF because it's kind of ridiculous. We've built up this system on top of the internet and are using all of these technologies, and it's supposed to be keeping us safe, and yet we've built up this entire economy around it. You saw the volume, you saw the search volume, you saw the volume of content. You use these apps every single day. You rely on them for your transportation. But the reality is that all of these systems, it's a house of cards. We don't have strong encryption at the base layer. We don't have a decentralized model today. So I like to make the statement, the castle is burning, right? It's like the front of the slide, how do we take back the web? Well, this bastion was supposed to be safe and secure, and it turns out it's flawed at the very foundations. And of course, our great protectors, the people we rely on for safety and security, are nowhere to be found. There's not much they can do anymore because the scale and scope of the problem has gotten so large that there's really criminals work around regulations anyways. The technology enables people to do things now, and it's just so deeply pervasive that all of these systems have the flaws, and there's no culture in the system, in enterprise really, to be certain that everything you publish online is safe and secure and encrypted properly. There is always another crack in the system because of the foundations being unencrypted by default. So poor configurations, bad software, and of course, there's nothing the government could do in the first place. So how do we do how do we actually do it? And it's making it encrypted by default, I think, is a necessary component. I think that not only do we need peer-to-peer infrastructure, but every single relationship needs to be encrypted peer-to-peer. So every single message, every single communication, encrypted by default. If you want to open something up publicly, you have to make an explicit decision to do so. Right? It's flipping the thing around, and it's making sure things are safe by default. So when things go online, any message you send is encrypted for your recipient only. And that way you can selectively disclose the pieces of information that you might want to share with a wider network of people. So this is privacy enforced and selectively disclosed. Selective disclosure is a very important concept. It's the ability for us to encrypt information and reveal a key later that is not our private keys, but is some shared third key that a third party can use to decrypt or have access to the visibility of that information without being able to modify it. Strictly peer-to-peer. We need to get rid of servers. We need to think about how to build the serverless web. And the way to do that, I mean, I think Bitcoin has offered one of the first large-scale working peer-to-peer networks that isn't entirely swarm-based. But this is really critical not only because we want to avoid central points of failure, but it also turns out to be much more efficient. For example, when you don't have to go find the local Facebook server, whatever it may be. They probably have servers all over the world at this point. You don't have to go find the one that's near to you. You can find a peer that may be even closer to you than the server who can give you the pieces of information that you're looking for. This actually turns out to be massively more efficient at large scale because rather than making round trips all around the world to have access to information, it's much more localized, right? And this allows actually the network to grow faster, it allows information to propagate faster because now you don't have to suffer from the load on your server of tens of thousands of people downloading from one. It's just like BitTorrent, for example. You spread things out and get chunks and pieces from the rest of the network. So this is an interesting one. This is actually what ultimately got me excited about working on this, is that we can actually, using mathematics, it turns out we should be able to prove the availability of free trade. By opening a market, and this is where I will get into the information markets piece, we can actually prove the properties to a probabilistic guarantee in most cases, but actually generate a proof. When you know the structure of the system and you know its behaviors and all of its potential outcomes, you can prove that trade was actually participated in, especially when you start talking about having zero knowledge. When you have no knowledge, no party has knowledge over the proofs that are being computed. You can actually write a proof that says, look, there is no knowledge transiting from this person to this person, therefore they are not influenced by this third party. So just to recap before I jump into the next section, we want encrypted by default. We want strictly peer-to-peer connections, so there are no servers. And we want to be able to prove actually that the trade is actually free, that people that are entering into voluntary agreements are not being coerced or influenced by outside parties until the trade is complete. So how do we do that? Well, we're going to have to go back a little bit because it turns out a lot of the assumptions that we made, just like I said with the centralized and lack of encrypted structure on the internet has resulted things. And think about, okay, well, how do we reimagine the relationship? And the fact that we can't rely on people to make privacy and security a priority, we kind of have to stand up for that. How do we really think about this as like is there a way to pair the two or to use them? Which one should we use? How? And really the answer is it's social systems as technologies. Okay, so it's using human behavior as the technology, right? Because human behavior is very hard to change. So how do we leverage existing human behavior to construct something that is that looks like what we're hoping to build? There's a really good example of this in the Bitcoin network, and I will explain why. So Bitcoin. I think we're all familiar with Bitcoin at this point. It works because of this idea of equilibrium, this idea of market demand and market supply. And while you cannot rely on individual actors to behave rationally, you can rely on a network of people to behave in sum as a net positive effect. So this is the wisdom of the crowds that's often related to in prediction markets. When you have, it turns out that the larger a number of people that you have of just generalized intelligence, the more accurate, and in fact you can surpass the accuracy of a group of experts. So a small panel of experts in a subject matter can be outcompeted by a large group of people operating in unison to make bets exactly on the outcome of something. And it turns out that this can give us not much greater, but a significantly larger amount of accuracy when it comes to results for things. And so basically what happens in Bitcoin is that the network security is mutually incentivized, right? So those that are providing the service, the miners who are producing the blocks, adding the proof of work to the network, are incentivized to actually keep the network secure, because otherwise there's no demand from the users, right? The users just simply, the users want the security of proof of work, but ultimately, if the miners were to collude and destroy, or maybe even get greater than a single miner getting more than 50%, there was actually an occurrence a few years ago with BTC Guild, where they got almost went up to 50%, but they decided, you know what, this would diminish the security of the system, so therefore we are going to stop accepting new customers, because that would just damage our revenue model. Because if it went above that threshold, well, now the system is less valuable and people wouldn't be willing to pay us for the security. So this was self-governing, at least in the beginning. And now we're starting to see other politics and other dynamics play out as different parties and groups think that they can compete with the wisdom of the crowd. What ultimately happens is this Nash equilibrium between the producers of the security, those that are mining the proof of work, and the demand for that security. Both parties want to reach the equilibrium because it optimizes for their cost function, right? So rather than the network, a single miner gaining a massive amount of capacity, they're much more incentivized to be fragmented and split up into groups, so that it's not likely that any one of them can become Byzantine or act maliciously, or that there would be a mistake and maybe something broke for whatever reason, a bug in the code. And this is the Nash equilibrium between supply and demand. So wouldn't it be nice if we could actually do the same kind of thing for code itself? And I scratched out law there, but what I really mean is, you know, when you write a piece of code and you distribute that code and you run that code, your computer is just following instructions. It's a machine. It's following a sequence of instructions. And if you think about it, that's kind of the way law works, right? We have a certain freedom that's constrained by law, but we have free movement within a certain space. And what I mean is we have the freedom to make decisions and act on our own. Code kind of operates the same way, but it's much more restricted. There's a specific sequence of operations that we are giving instructions to the machine to execute. And wouldn't it be nice if we didn't have to rely on a single central server to execute these things? And it turns out we can. So this is where I explain information markets. It's a very broad term, and I'm hoping that a lot of the crypto-anarchists in the room are familiar with its reference in the Crypto-Anarchist Manifesto, which is pinned on the back of the board back there. So if you haven't looked at it, please do. But this is the snippet, and it basically points out that information markets, the ability to use information markets is something that's going to empower people. And if you follow the surrounding text, they talk about how, or Tim talks about how things can be, we're really tearing down the barbed wire, if you will, that's the fences that have been put up around access to information, because now we can freely trade it. So if you have a piece of information, now I can sell it to someone, right? And when we are all empowered to have that ability, all empowered to buy and sell information, then we can take back the power and the control from the centralized institutions that have taken it from us. So information markets are just buying and selling information. Well, what is information? Information, it turns out, is pretty much everything. When you get down to the quantum state of the universe, right? If you want to subscribe to quantum field theory, or quantum gravity, or string theory, or any number of the prevailing theories today, actually I think string theory's out at this point, it all boils down to information. The state of the universe encodes information in the matter and the energy that we interact with on a daily basis. And there's some interesting properties about information that we can measure and even prove. I think this is the only math in the presentation, so bear with me. Okay, so this is basically this is how you measure entropy in a system. And what this equation gives you is a likelihood of a piece of information flowing into a system on a discrete scale. That's actually a very important part here. So over time, if you put a specific message in, or a specific signal, or a specific piece of information, as the system progresses, as time goes on, it becomes less and less likely for you to be able to recover that signal. Because entropy expands. It expands to fill the space available, and the universe seems to have a universal law that without coherence, without intentional control and merging and keeping things in order, man, things just seem to spread out and expand and try to migrate towards a state of entropy. And entropy really means it's a measurement of randomness, of distribution of information. What are the implications of this? Well, it turns out information can be lost, right? One of the prime examples of this in the universe is a black hole. When light or matter passes over the surface of a black hole, that information is lost. It's stretched out to, it's presumably lost. We still have a lot more to understand about that. But it looks like what happens is the information is completely consumed by the black hole and eventually radiated back out in the form of Hawking radiation. But that whatever was put in there, whatever matter, is completely decoherenced and destroyed, and you lose that information. And this is actually a really important property. We talk about blockchains all the time, and the Bitcoin blockchain has this amazing property of being immutable, meaning once something is in the chain, it's probabilistically unlikely for it to be lost again. Once something's in there, and it's in there pretty deep, it's permanent. But it turns out, you know, sometimes you don't want information to be out there, right? In the case of maybe private transactions, it doesn't make sense, unless you can truly encrypt everything for a long period of time, for that information to be stored in a record somewhere. I mean, we're seeing all of these talks and all of these presentations now. It's very easy to keep track of Bitcoin transactions as they flow through the system. And the only answer that many systems have is mixing, which, of course, you know, you're just mixing other people's coins who want them to be mixed. So now you kind of end up with the same thing on the other side, just a different color of your crime. So wouldn't it be better, actually, if when we committed a private transaction and we made an agreement with one another, that all of the information was destroyed, completely eliminated from history, but still somehow trackable in terms of being able to spend what you received? A true cache, where there was no central record of account, but something much more peer-to-peer. So this is where I talk about the measurement of entropy and the generalized social construct of migrating towards consensus. So this is a map of fields and how they're using calculus, but fields and how they come towards a Nash equilibrium. Okay, so you might have miners on one side and users on another. The Nash equilibrium kind of pulls everyone forward and towards a specific objective or state. So what does that mean when people kind of come together and are interested in establishing a shared truth that can be referenced? What does that mean when people accomplish a Nash equilibrium? Well, it's a balance between this idea of entropy, this chaos and loss, and the coherence, the order, the structure, the mutual agreement of trust that we all have. Okay, so I'm going to pick up the pace here just a little bit so we can get to questions. But this is what that looks like over time. Basically, there is a state in the early phase where each force rises to its maximum, and eventually they sort of neutralize out and achieve an equilibrium between the two. Okay. So this is where we can balance the entropy and the deletion of information with the idea of picking and choosing the information that we keep because it's of shared value to everyone who's participating in the network. So buying and selling network services is really the next leap of thought. It's this idea that information can be the result of a computation. The information can be a result of a series of instructions that maybe I've distributed, and everybody's aware of the instructions, but they're not necessarily aware of the data. So it turns out when you can distribute computations on the network, you can also earn quite a bit of money for computing things for people. For example, scientific compute. Wouldn't it be nice if SETI at home or folding at home resulted in some sort of reward? We're going to jump through the routing stuff. Basically, it's a what we're building is a broadcast network. And anyone who's able to successfully complete the transaction can then broadcast the solution back. Well, how do we do that? Number one, payment channels. This is a way of establishing a peer-to-peer agreement between you and another party who has a shared point of reference. So for example, the Bitcoin blockchain, as long as we agree on the current state of the blockchain, we say, okay, good, we can form a contract between the two of us, a Bitcoin transaction that lasts a year, and it doesn't get broadcast until the very end. And what we do is we just modify the amounts that are included in that transaction and re-sign it. Oops. Re-sign it every time. And then only when one of us decides that we want to settle or put it back in the main chain do we do so. That's payment channels. Now this is actually the most powerful thing here, I think. It's zero-knowledge contingent payments. And this is a technology that's possible today. In fact, this is something that was done on the Bitcoin mainnet last year, early last year. Using the smart contract language built into Bitcoin, it's possible to make a payment to someone in exchange for solving a puzzle, really, for computing some amount of work. And then by computing that work, you automatically unlock the payment. But you can't do so without computing the work. And this is how we do a broadcast network without having to do additional round trips between the participants. We can actually broadcast partially complete orders that once someone computes them, they can claim the payment that's associated with them trustlessly. So one of the additional ideas that we've come up with is state bubbles. And these are actually just like a prime number field. You can compute information across a state bubble. Once you've computed a path through a state bubble, you now have the solution. You have a potential solution to a pathing system through that for a particular answer that you're looking for. And we do this by applications sharing their databases with one another in a mathematical way. And you can compute things across that space. And when you come to the particular answer that you're looking for, you now have a solution. And this can be controlled much in the same way that Bitcoin's proof of work can be controlled in terms of difficulty, based on controlling the size of the space. I'm just going to skip through this and get to questions. We can build serverless apps this way by distributing components of applications, dividing computer programs into smaller pieces, and then combining the results over time, which means that no one party actually even has access to the computations, let alone being able to see what the actual results might be. So that verify step, we have a deterministic application, so we do want determinism. Randomness can be introduced. We have measurements of entropy in the system. If you want to have a pseudo-random number generator, you can. But ultimately, we want verifiable computations. So here you might compute the program that's been instructed. You generate an output. The prove step is actually a mathematical proof that the computer program executed what you anticipated it to execute. Okay? This means that we actually cannot have Turing completeness at the protocol level. At the level of the program cannot be Turing complete. We have to be able to predictably prove the outcome of the programs, and only then can individuals be certain as to what a computer program will do and make effective and safe decisions about which contracts they want to fulfill versus which contracts they do not. And then, of course, the broadcast. Just real quick takeaways. We can jump straight into questions if you'd like. I know we're running short on time.
Thank you very much, Eric. Yeah. Thank you. I think the concept seems and sounds very nice. I wanted to ask a question, but I've already noticed some. So Okay, my question very briefly, how could we participate and in which level broadcast network is now?
Sure. So we have a network called PlayNet, which is a sort of a pre-configured network of applications that we're building already on top of the network. We have an open source library called Maki, M-A-K-I, which our goal is to help people build these deterministic, strongly typed, functional systems. But for a lot of web developers, that's kind of hard, right? They're not necessarily familiar with the technology. So we've built a framework that basically helps developers build and target what the next web will be. Perfect. So we can check it out online.
Thank you very much. Which website, maybe?
Maki.io, yeah.
Perfect, thank you.
Cheers. Thanks for your presentation. It's quite refreshing. And I love your hat. My mate pointed it out. I hate what happened to Ethereum.
Yeah, for sure.
Anyways, besides that, you spoke about decentralization, which I really appreciate. I'm a big advocate of decentralization. My worry is that at some stage, it will become like VPN, right? We will become this hype word where corporations will just say, oh, you guys want a decentralization? Here, we decentralize that data now, and no one, hacking has been reduced. Is that even a possibility? Well, it's kind of like a combined question. Is that a possibility? Why isn't that taking place? I would assume something to do with accessing data or control or something like that. But I guess I can imagine multiple corporate entities such as the R3 initiative getting together and saying, let's decentralize our data across all these data centers that we kind of own and operate. It wouldn't be a bad thing, but I would hate for that to become the hyped or product version of what VPN is, like these stupid companies offering VPN, which collects all your log and everything anyways. You might as well not have a VPN. Yeah, and I would hate the same thing to happen to decentralization. So if you have any comments or share thoughts or anything.
Yeah, so I think the question is getting at, so why wouldn't someone with a large body of compute power just kind of step in and take it over? Or is the question much more about, well, let me just talk to that for a second. So centralization is actually generally much cheaper than decentralization. So there's a built-in intrinsic desire for large for-profit companies to centralize as much as possible because it's much more efficient for them. Now, there is an increased efficiency loss when if they were to see what's possible with decentralization and to say, well, it actually reduces our costs because we can distribute the load across this wider network. If you end up with that situation and they have these centralized services, you lose the efficiency gains of having the information close by, right? The market, the people who see this information, we want to make sure that you can resell information. Because after all, if you have a copy of something, you should be able to resell that as well, with full recognition that what the original author was and making sure that there's a fair arrangement between those people. So what should happen, even if these large institutions move in, is that yes, while there may be an initial bundle of content, there's a limited time that it stays centralized. The network naturally will diffuse this content across the network because everybody has the opportunity to participate in the servicing and sharing of this content. And ultimately, the thing that will restrict them from doing this is the cost of change, right? Right now, they've built up their entire business models around centralization. At the end of the day, you have to provide some service or good in order to make money, or you have to scam people, right? So, and I anticipate in a world where information is freely traded, that scamming will become much more difficult, and so these large centralized institutions will eventually die out.
Thank you. I just add that on the head there is make Ethereum immutable. Thanks.
Yeah.
I think last question. Who wants to ask a last question? There is.
You talked about serverless web, and then you use torrents as an example.
Sure.
And they need a server.
Storage?
No, not for storage, but for when you connect to find the peers.
To find peers.
Yeah,
Okay,
so it's like, how do you
Sure.
fix this?
So Bitcoin solved this problem in a couple of different ways, and currently it uses DNS seeds. So it's the ability to say, connect to this DNS address, whatever it points to, and that will give you a list of the available peers in the network. Okay, right. So a content addressable network, when you download the code to run, say, the Fabric node, it comes with a list of the addresses, just like Bitcoin Core might include a list of here is where the first six peers are. Okay, and then you should be able to build trustlessly without having to, as long as you trust the initial download, which is also another question. So.
Perfect. Thank you. Thank you very much.
Great question. Thank you.